These slides are for triple chemistry. Higher tier triple gets the most calculations, so let's look at Avogadro and the mole. The mole is called the chemist dozen. 1 mole equals 6.02 times 10 to the 23 particles, and that number is Avogadro's constant. You rarely use the raw number, and what you need is the link. Moles equals mass over relative formula mass. That single formula does almost every paper 1 calculation, and you rearrange as needed. Show the rearrangement, show the substitution, and show the answer with units. Reactant masses. If you know moles of one reactant, you know moles of every other reactant and product. The balanced equation gives the ratio. There are 3 steps to do this. First of all, you balance the equation. Secondly, use moles equals mass over relative formula mass to get moles of what you know. 3. Use the ratio in the equation to find moles of what you want. Convert back to mass if needed. In the exam, the mark scheme rewards the working and not just the final number. Always show the ratio step. From the equation, 2 moles of X give 1 mole of Y. So it's about balance, moles, ratio, mass. Limiting reactants. The reactant that runs out first is the limiting reactant. It controls how much product forms. So to check it, calculate moles of each reactant. Divide each by its coefficient in the balanced equation. The smallest number is the limiting reactant. In the exam, once you know the limiting reactant, only use that for the rest of the calculation. The other reactant is in excess and doesn't matter. So smallest moles per coefficient, and that's the limit. Percentage by mass and empirical formula. These are 2 related calculations. Percentage by mass tells you what fraction of a compound is 1 element. Empirical formula is the simplest whole number ratio of atoms. For percentage by mass, mass of element in the formula divided by the total relative formula mass times 100 because it's a percentage. For empirical formula, start with mass or percentage of each element. Divide each by its atomic mass to get moles. Divide all moles by the smallest. Round to whole numbers, and that gives the ratio. In the exam, if percentages add up to less than 100, the missing element is usually oxygen. Add the difference and then proceed. So mass, atomic mass, smallest, ratio. Yield from limiting reactant. Percentage yield is actual mass over theoretical mass times 100. For triple, you may have to find the theoretical mass first from the limiting reactant. There are 3 steps to do this. 1. Find moles of the limiting reactant. 2. Use the equation ratio to find moles of product. 3. Convert moles of product to mass using mass equals moles times relative formula mass. The actual mass is given. Divide actual by theoretical times 100. In the exam, yield is never above 100%. If you do get above 100%, you've made an error, and usually in the ratio step. So theoretical first, then actual over theoretical times 100. Titration calculations. You're given the volume and concentration of one solution and the volume of another. The aim is the concentration of the unknown. And there are 4 steps to do this. First of all, write the balanced equation. Secondly, find moles of the known solution using moles equals concentration times volume in decimeters cubed. The third step, use the ratio in the equation to find moles of the unknown. And lastly, divide moles of unknown by its volume in decimeters cubed to get its concentration. In the exam, convert all volumes to decimeters cubed first. The unit trap often catches candidates out. So balance, moles known, ratio, concentration unknown. Molar gas volume. 1 mole of any gas at room temperature and pressure occupies 24 decimeters cubed. So volume equals moles times 24. Or moles equals volume divided by 24. In the exam, if a question gives volume in decimeters cubed, divide by 24 to get moles. If in centimeters cubed, divide by 24,000, so watch the unit.